Hello guys, this is an arithmetic series video. In this video guys, we are going to remember first what is an arithmetic sequence. When we have an arithmetic sequence, it's because we have this situation. Arithmetic is when we are going to add or subtract the same amount and again and again and again. For example, here we have from 3 to 6 to 9 to 12. We are adding 3. So this 3 is known as the common difference. And pay attention, sometimes the sequence is decreasing, so we can have a negative common difference because it's decreasing 10, 7, 4, 1, minus 2. Okay? Then, now that we have arithmetic series, this is the new thing, a series. When we have an arithmetic sequence like this, it becomes a series where we need to calculate the sum of these values. If we need to find the 3 plus 6 plus 9 plus 12 plus 15, now it becomes a series. And obviously, we have a formula to find the sum. So we can say an arithmetic series is the sum of terms in an arithmetic sequence. Okay, this is the formula. We are going to analyze super fast the meaning of each variable. We have this situation. Sn means the sum until the position n. Remember, every single number has a position. If we have this situation like 2, 4, 6, 8, every single number has a position. For example, position 1, 2, 3, and 4. Okay, so this S means the sum until the position n. If we need to find the sum until the position 4, it's going to be like 2 plus 4 plus 6 plus 8. Okay, then n is the number of terms or the position. Okay, n is the position. Okay, then what is U1? U1 is the first number of the sequence. U1 in this case would be the number using the position 1, in this case the number 2. Then super important here, UN is the last number that you want to sum, to add. Okay, so if we are using this is super easy. We are saying I want to find the sum until the position 4. The last number is going to be the number using the position 4, in this case 8. So be careful, because there are some exercises that we do not have this number. Remember, it's the number using the last position, it's not the position. Okay, so we are going to do this easy peasy example. Okay, we have this situation. We have 1. Calculate the sum of the first 20 terms of the series 60, 57 plus 54. Okay, so as you can see, we have this. Okay, and so on. So pay attention. We have positions, position 1, 2, and 3. Okay, this is the n, means position. Okay, so we need to find the sum until the position 20. Okay, that is the key, that is the question. So how? As you can see, we do not have the number using the position 20. We don't know. Okay, in that case, because there is a number here, there is a number using the position 20. Okay, let me do this bigger. There is a number using the position 20 that we don't know, but we need this number because if you remember in the formula, we need the position 20, the first number of the list 60, okay, then the last number, the number using the last position that we need to sum, in this case 20, but we don't have the position 20, the number using the position 20. What can we do? In those cases, we need to use first this formula. If you remember, this is from arithmetic sequences. Okay, this is the way that we can use that we can find the number using the position 20. So that would be the first step. Number one, finding the number using the position 20. This means the number using the position 20. Okay, so using this formula is going to be like this. The number using the position 20 is the first number. Pay attention. I am following this. Okay, the first number is U1, 60 plus the position that we want, 20 minus 1 times the common difference. What's the common difference? The common difference is minus 3. Okay, as you can see here, is decreasing by 3. So this is super important because this is a negative 3. Okay, so this is 60 plus 19 times negative 3. Okay, so here what we can do is to use our calculator to find the result. In this case, the number using the position 20 is going to be 3. Okay, so using your calculator, you can find this number. Okay, and that's it. So this is first the number using the position 20. So once that we have this number, let me use here, this is 3. Okay, now we can use our new formula. Which formula? This one, for finding the series, the sum. Okay, so finding the sum. Okay, so pay attention here. We need the sum onto the position 20. Okay, so this will be something like this. Let's use purple. We have the sum onto the position 20. Okay, it's going to be n. N is the last position, so it's 20 divided by 2 times the first number. I am following this. Okay, so the first number is 60 plus the last number, 3. Okay, so basically this is 20 divided by 2 is 10 times 63. So the sum until the position 20 has to be 630, and this is the result of the exercise 1. The sum of the first 20 terms. So summarizing, if we don't have the last position, we need to find this number by using this formula first. Then we can find the sum onto the position 20. Okay, guys, so then to complete the example, we have number 2, find the sum of the arithmetic series. Okay, and then we have minus 10, minus 6, minus 2. Okay, so pay attention here, what is happening. So first we have this minus 10, this is the sequence, then minus 6, then minus 2, then plus 20, sorry, plus 90. Okay, so this is 90. So first we need to find, well, we need to remember first that we have positions, position 1, position 2, 3, this is n, then this one, we don't know the position. Then what else? We need to find the common difference. Okay, the common difference. So how can we find the common difference? Okay, this is a reminder. The common difference is super easy to find. First, we need to take 2 consecutive numbers. For example, these 2. Okay, the number minus 10 and minus 6. Then what we are going to do is a subtraction. We are going to take 2 consecutive numbers, and as subtraction, we are going to take the number minus the previous number. Pay attention, minus the previous number. So we need to take first the negative 6, minus 6, minus what? Minus 10. Okay, again, taking two consecutive numbers, then we take this, a number, minus the previous number. So because of the word previous, we need to take first this. Okay, so this, pay attention, because we are going to use the signs rule. We have minus times minus, or negative times negative, it becomes positive. So it's like, basically it's like minus 6 plus 10. So this is a positive 4. So this is the trick. We have a positive 4, and this is the common difference. So it's increasing by 4, by 4, by 4. Okay, so this is plus 4. Then this is D in our formula. Then what else? We need to find, okay, there is a problem. This number, we have the number, but we don't have its position. Okay, we don't have its position, and we need the position, because if we want to find the sum, pay attention. If we want to find the sum until the position, what? Which position? We don't know. Pay attention. If we want to use this, and this is the first number, minus 10 plus 90. Okay, the problem here, guys, is that we don't have n. We don't have n. We already know that this is 90, but it's using a position that we don't know. So in order to find this position, okay, we need to use first the formula from arithmetic sequences. Again, this one, okay? But now we are going to use it to find what? Finding the position. Finding n, n is the position of the number 90. Okay, so finding the position of this number 90, because it's the last position, and we are going to use this position here. Okay, here comes the trick. If you remember this formula, this one, this un means the number using the position n, and we already have the number. That is the reason that we are going to use this equation. 90, the number using the position n, okay, the 90, is going to be the first number, minus 10, plus n that we don't know, the position that we don't know, minus 1 times the common difference. In this case, 4. This is the common difference. Okay, then what else? Here comes a trick. Our goal is to isolate the n, because it means position. So we can do some algebra. What we are going to do is to multiply n times 4, and then the negative 1 times 4. So pay attention. What we are going to do is this. 90 is minus 10 plus n times 4 for n. The negative 1 times 4 minus 4. So here we can simplify. We can say 90 is minus 10, pay attention to this, minus 10 minus 4 is minus 14 plus 4 times n. So here the goal is to isolate n, because n is the position. Okay, so we need to isolate n. So what can we do to perform the opposite operation? This is a subtraction. This is going to be an addition. So we have 90 plus 14 equals 4n. Obviously this is 104 equals 4n. Again, the opposite operation. This 4 is multiplying the n. What is the goal? To isolate n. So we need to move the 4 by using the opposite operation, in this case a division. So 104 divided by 4 equals n. N, our n, is 26. You can perform this in your calculator. This is, okay, 26. This is only to find the position, okay, the position. What is missing? To find the sum. So now we are super sure that this position is the position number 26, okay? Now we have position and the number. So we are super ready to use the new formula, okay? Here, if you remember, is the sum until the position 26 is going to be what? Pay attention to this. Okay, let me copy the formula here. Let me copy the formula here. This is our formula here. Okay, so if you remember, this is the sum is the sum until the position 26 is going to be the position 26 divided by 2 times the first number of the list plus the last one. What is the first number? Pay attention here, minus 10 and 90. So this is minus 10 plus 90, okay? This is the first position, the last, now the number 1. Now let me show you this one. This is the number using the position 1 and the number using the last position. Okay, so finally, the sum until the position 26 is going to be 13 times 80. Okay, minus 10 plus 90 is 80. So we can do this, and that's it. This is 140. And that's it. This is the sum until the position 26. So pay attention, because in this example, what we need to do first is to find the position of this 90. And that's it.